This is the Chapter 11 Statistics Chapter, Review Part A. It's also Unit Test 4. So in problem number 1, they ask you to find the mean, median, and mode of the following set of data. So what you're going to do is you're going to start by putting the numbers in order. And we always like to put them in order from least to greatest. So I'm going to start with 78. And then the next number up from there is 100, and you'll notice there are two of them. And then there's 112, and there's two of them. And then there's 120. I like to cross them off just to remind myself I use them all. So let's start with the mean. The mean you get by adding those 6 numbers together and dividing by however many numbers you added. When you add them, you should get 622 divided by 6, which is going to be 103.7. The median is the middle number. But what happens when there are an even set of data? Well, when you have an even set of data, you have 2 numbers in the middle. You're going to add those together and divide by 2. And you're going to get 106. And then the last question is, what's the mode? Well, in order for there to be a mode, there needs to be a number that occurs more than once. And it happens that there are 2 numbers that both occur twice. So we say that both 100 and 112 are the mode. We call that bimodal. Now, in order to find the mean, remember there was another way that you could do this. In order to find the mean in the calculator, you can put this set of data into list 1 under the stat menu. And then when you go back to stat calc, you could use one variable statistics. X bar is your mean, and it should also tell you 103.7. In number 2, it says, I have a temperature gauge in my car, which if the weather outside says low, it's actually, I'm sorry, this is so poorly worded, it makes me want to cringe. So let me rephrase this. The car, for some strange reason, does not tell you the temperature outside if it's below 0 degrees. So if it's below 0 degrees, the car just says that it's low. The readings I took in December were 12, 25, low, 13, 15, low, low, 15, and 26. Can you find the mean, median, mode, or range, standard deviation, or interquartile range of these values? Well, let's start by putting these in order. Remember that we said low just meant that the temperature was below 0. I don't know what the temperature was, but I know it's less than 0. And there are 3 of them. So there's low, 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 12, 13, 15, 15, 25, and 26. Make that actually look like a comma. Okay, so what kinds of information can I find from this list? Well, I do know how many readings I took. I clearly took 1, 2, 3, 4, 5, 6, 7, 8, 9 readings. So if I took 9 readings, I can find the median. The median's the number in the middle. But in order to find the mode, I can't say what the most frequently occurring number is because all of these could actually be the same number, or they're maybe not. I don't know. So I don't know if I have a mode or not. The mean. In order to find the mean, I need to be able to add these numbers up and divide by 9, except that I don't know what those numbers are. So if I don't know what they are, I can't find the mean. In order to find the range, you need to know the minimum and the maximum. But I don't know the minimum, so I can't actually subtract them. In order to find the standard deviation, I actually need to know all the values. The interquartile range is the distance between quartile 1 and quartile 3. And although I can find quartile 3, I can't find quartile 1 because I don't know what those numbers are. So the only piece of information that you can get from this list is the median. In number 3, a news reporter wants to talk about how cold the winter is. The temperatures over the last 5 days were -15, 0, 2, 3, and 4. Which measure of central tendency should she use? Well, the first thing that I want you to notice is that negative 15 is an outlier. You got to watch out for that because it can skew your data. So if you have an outlier, which measure of central tendency is going to end up being the best to represent this data? Remember, the measures of central tendency are mean, median, and mode. First of all, there is no mode. So if there's no mode, it's not very helpful. The median's easy. The median is 2 because it's the middle number. If you were to actually go find the mean and add those numbers and divide by 5, you should find out that the mean is negative 1.2. So let's look back at this list of data again. You have these 5 temperatures. Do you think on average it was negative 1.2 degrees when most of the temperatures were 0 or above? Look at what the outlier did to the mean. It skewed it to the left. So the best measure of central tendency tends to be the median, particularly when there's an outlier. In number 4, a student wants to know his grade based on the fact that the teacher gives 20% of the grade based on participation, 30% is based on homework, and 50% is based on test. So if the participation score is 90%, the homework score is 85%, and the test score is 68%, what is his grade? So we know from this problem that 20% of the grade is participation. So that means you're going to multiply 20% times the participation grade, which they told me was 90. The only percent that gets turned into a decimal is the 20% because their percent for the participation is 90, so we want to find out what 20% of that percent is. The homework grade is 30% of the grade, so we're going to multiply 30.30 times the homework percentage. And then 50% of the grade is from the test scores, so we're going to do 0.50 times the test score. And then we're going to add those together. Well, luckily, that's something that you can just shove into your calculator as is. And if you shove it in correctly, you should find out it's 77.5%. So this student would have a C. In problem number 5, the standard deviation of the following test, or find the standard deviation of the following test scores. 190, 185, 188, 235, 246. So you can do the chart if you want, but you know the chart takes a really long time. The easiest way to find the standard deviation is to plug this into list 1 under the stat menu, and then go back to stat calc, to one variable statistics. The standard deviation is sigma x, and it should tell you that it's about 26.2. For number 6, if in the score above, you forgot to include 200 for a test that you forgot to make up, what happens to the standard deviation? Well, this is what I would do. I would go back and I would go put into stat 1, I would add the 200. So instead of having 5 scores, now I have 6. And then I would go back and I would find the standard deviation again. Well, if you do that, you should find out the standard deviation is 24.1. So forgetting that score lowered the standard deviation. In number 7, a data set has a mean of 85 and a standard deviation of 7. The highest score was 4 standard deviations away from the mean, is what it should say. What is the highest score? So if you draw your little normal distribution curve, and you know that the mean is 85 and the standard deviation is 7. So let's start at 1 standard deviation away. 85 plus 7 is 92. A second standard deviation away is going to be 92 plus 7, which is 99. The third standard deviation away is 99 plus 7, which is 106. And the fourth standard deviation away is going to be 106 plus 7, which is 113. So it turns out the highest score was 113. In number 8, a calculator gives you a mean of 95, a standard deviation of 8, a minimum of 77, and a maximum of 104. How many standard deviations is this range? So the first thing I got to do is go draw my curve. I should probably make my curve a little bit bigger. Okay, so let's start with the mean is at 95. The standard deviation is 8, and so this time I'm going to actually have to go in both directions. So one standard deviation away is going to be 103 this direction and 87 this direction. Well, right now I haven't encompassed all of my data points yet because my minimum was 77 and my maximum was 104. So my maximum is 104. I need to go another standard deviation this way. So 103 plus 8 is 111. And 87 minus 8 is 79. Here's the problem. Even though I've hit my maximum, I haven't hit my minimum yet. My minimum's 77. So I have to go one more standard deviation out in order to encompass all of my data. And the problem is I can't just go another standard deviation in one direction and not the other. I have to go in both directions. So if 77 is over here and 104 is over here, in order to get all of my data, I need to go within 3 standard deviations from the mean to encompass my entire range. In number 9, you ask your friends, how do you feel about metal detectors? What kind of sample is this? Well, because you're asking your friends, it's probably a convenience sample. It's not systematic because you're not asking every third friend who walks in the door. It's not random because you know these people. And it's not self-selected because they're not volunteering. Number 10, you have 20 volunteers that all want to lose weight. You give an experimental drug to 10 people and a placebo to 10 people, and after 8 weeks, all of the people lose weight. What conclusion should you make? Well, if 10 people got the drug, but another 10 people didn't, but everybody lost weight anyway, can you tell if this drug actually caused the weight loss or maybe it was something else? So when you're writing your conclusion to this, please use complete sentences. So I would probably say, you cannot conclude that the drug caused the weight loss since the participants on the placebo also lost weight. It basically explains what happened and it's in a complete sentence. Number 11, we ask 100 random people about the money spent per customer at a grocery store. Should probably clean that up a little. We asked 100 random people about how much money they spend maybe each week at a grocery store. This is an example of we call it just a simple random sampling. Why? Because they told me it was 100 random people. It's not necessarily convenience because they didn't say it was done at the grocery store. It's not self-selected because these people didn't necessarily volunteer. It's definitely not systematic. So we have only one other choice, and that's our simple random sampling. The last 2 problems I'm going to talk about in part 1 are 12 and 13. Number 14 I know is at the bottom of this particular screen. We're going to cover that in part 2 of the review. In number 12 it says, how would you do a systemized survey of the value of education of the students of Waukegan High School? Notice the key word here is systemized. So you need some way of how would you survey them in a nice systemized way. So there's really no one right answer. So here's the answer I'm going to give. I'm going to survey the every 10th student who enters the building. Is that the only way of doing it? No, I mean, you can do every 10th student. You can say, I want to survey every 3rd student or every 5th student. That's one way of doing it. What's another way you could do this? You could put all the ID numbers in a random number generator and then generate out student IDs and just survey those people. That's going to give you a nice random sampling of everyone in the building. Number 13. The score on an IQ test is normally distributed with a mean of 100 and a standard deviation of 15. Which interval has 99.7% of the data? In order to determine that, we're going to draw the picture. So here's my picture. Here's my mean. If my standard deviation is 15, that means I got to go 15 this way and 15 this way. That's one standard deviation away. Remember, that's 34% of the data and 34% of the data. Remember, I'll give you this on the test. You don't have to have it memorized, but you might have used it enough that you'll probably have part of it memorized. Okay, a second standard deviation away is going to be 130 to the right, and your second standard deviation to the left is going to be at 60. Well, I haven't quite hit my 97% yet. This is 13.5 and this is 13.5. I'm only at my 95%. So in order to get to 99.7%, you have to go to a third standard deviation. So this way it's going to be 145, and this way it's going to be 45. And this is 2.35% and 2.35%. So 3 standard deviations away from the mean encompasses 99.7% of the data. So what's my interval? My interval is from 45 to 145.